All right, guys, welcome to Quarantined Math Analysis for April 2nd. What we're going to talk about today is something that we see in the second half of the problems on that first page of derivatives, and that is things like this. Roots to some power of x, because these kind of throw a wrench in our plans. We've talked a lot about, or a bit about, what we do when we see exponents on our variables and how those multiply the coefficients and all that kind of thing. But what do these do? This is a really weird situation. Now we're going to answer that question specifically in tomorrow's video. But today we're going to talk about a better and probably easier way for you to write these type of roots as exponents. So here's what I want to point out. If you had the sixth root of x, this is the same thing as writing x to the 1/6 power. Now, this is kind of unusual, but once you do a couple of these, it's going to be really easy to get the hang of how to translate between these two. What happens is, any fractional exponent is actually a version of a square root, or a radical, I guess I should be saying, since a square root is specifically a second one. So here's what happens, and I'm going to represent this in variables so you can see how things move around. If we had x to the m over n power, then you could rewrite that fractional exponent as the nth root of x to the m power. Here's what I like to think personally. The denominator of the fraction comes around and makes a root. And then the numerator of the fraction just kind of falls down to be the exponent to the original base, or the original number that we had there. So we're going to do a couple examples of this. So if we had something like x to the 2/3 power, then what we could do is we could look at that denominator. That's going to become the root, so the third root of, and then that 2 is just going to kind of fall into place as being the exponent for the x, so the third root of x squared, just like that. Now, we don't usually see the fractional exponents in our worksheet with the derivatives. We see them like this, the other way around. So we're going to try to convert back that way. Now, I do want to mention, if we had something like this, x to the 1/3 power, then that 3 comes around as a cube root, and then the 1 falls down to be with the x. But we don't actually have to write that there. Any variable that doesn't have an exponent written next to it has an exponent of 1. It's kind of like the invisible 1 coefficient idea. I want to make sure I get that out of the way before we move on to this next thing here. So if we had the other way around, we had something like the 5th root of x, just like that, then what we could do is we could look at it and say, well, the way of writing it would be as x. That's our base of sorts, right? We know 5 is going to be the denominator to its fractional exponent. And then the variable, sorry, not the variable, but the number that is currently its exponent is going to be the numerator. We don't see a number there, so we assume, or actually we just know, that it's 1. So the 5th root of x would be the same thing as x to the 1/5 power. That's how I got this at the very beginning, saying the 6th root of x is x to the 1/6, because its denominator is what root we're taking, 6. Its numerator is its variable, or not variable, exponent, underneath that radical. We'll do one with multiple numbers here. We don't really see these with the derivatives problems, but in case it comes up, it'll be good to know. If we have the 4th root of x to the 3rd, then what we could do is write x We know its fractional exponent is going to have a denominator of 4 because that's the root we have. And its numerator is going to be 3 because that's the exponent it has underneath the radical. So the fourth root of x to the third is x to the 3/4. I'm going to write a couple questions on the page here. You can pause the video after I write them. I want you to think about what they would be, maybe jot down what they would be equivalent to, whatever it may be, and then unpause the video and I'll go over the answers. So let's try out x to the 7/9 power. Turn that to be written as a radical. And then we'll do the 7th root of x to the 4th. Go ahead and try to write that as a fractional exponent. Okay, well hopefully you paused the video, tried that out. So what we do here, we take the denominator. It is written as a root or a radical, whatever word you want to use. And inside there is x to the numerator's power, x to the 7th. Down here, we're going to be swapping that, or kind of doing the opposite of that order. We have x, our variable, in there. Its denominator is going to be what the root is, so 7, and its numerator is going to be what's in here, 4. So x to the 4/7 power. Now, all of this is going to come up in our next set of derivatives problems. Again, the reason I wanted to talk about it today is because we see in several of those problems things like this. And since it would be really difficult if we had a coefficient there and then this to know, well, what multiplies that coefficient? What do we do? You know, it kind of breaks that mold from what we're familiar with the derivative power rule. If we rewrite it in a form that we're a little bit more comfortable with, like fractional exponents are still kind of scary, I agree, but we're a little more comfortable actually seeing that exponent there, then we'll have a better place to start looking at solving those problems. So tomorrow we're going to jump in, we'll solve some more of those problems on that first page of the packet, and we'll keep it rolling from there. See you guys then.